NCERT in-text question number 6. It gives an equation which is ionic equation, and E naught cell value is provided at 298 Kelvin. Calculate the standard Gibbs energy and equilibrium constant of the cell reaction. So here you have two things to do. One, standard Gibbs energy, that is delta G naught, and equilibrium constant Kc. So what formula to use? First we will see delta G naught. So delta G naught is equal to minus NF E naught cell. E naught cell is provided. What is N? How many electron transfer has taken place? For that we need to see Fe3 plus 2 moles of it takes 2 electron and forms twice Fe2 plus. Whereas 2I minus gives out 2 electron and forms I2. So it is like this, where we can see there is 2 electron transfer, and so N is equal to 2. So when you place the values, what do you get for delta G naught? Minus N, so minus 2, F is 96500 into E naught cell, which is provided 0.236 is already provided. So this comes out in the unit joule per mole, and the value is coming minus 45548 joule per mole. This is the value. Now I can convert it to kilojoule per mole. In that case, I will get 45.55 kilojoule per mole. That is, what will I get over here is divided by 1000. And again, I know that if I have to find Kc, the relation of delta G naught with Kc is minus 2.303 RT log Kc. So in that case, I can find log Kc first. So to find log Kc, what we need to do is log Kc is equal to minus of delta G naught by 2.303 RT. The value of R will depend which unit you want to take. So I have kept kilojoule per mole over here, 45.55 kilojoule per mole. So this will be taken as 2.303 into 8.314 into 10 to the power of minus 3, because I am taking the unit kilojoule per Kelvin per mole into 298 Kelvin. So here the value will come out to be 7.983. This will be 7.983, and so what you will get is log Kc is this. So Kc is equal to anti-log of 7.983. You can keep your answer till this.